Okay, cool. Hi. Hi, Bay Area React. I'm Sean. I also go by Swix. That's my initials. I work on developer experience at Nullify. Heads up, who's used Nullify here? Okay, a lot more hands need to be up, so just go home and check it out. It's a front-end developer's best friend, DevOps as a service. Go check it out. I'm actually not local here. I'm visiting from New York. I'm here to spread the love. And it's my first time at Bay Area React, so I'm pretty excited to share some stuff with you guys. I'm also a moderator on the r/React.js forum. There's 77,000 of us talking about React. We post jobs in React. If you're hiring, definitely post there because it's a free job board. And I'm at Swix on Twitter. But the thing you really care about is the future of React. So we're going to talk about the future, and particularly 3 features of the future of React: React Suspense, time slicing, and hooks. There is more, actually, but we're not going to talk about those things just because we don't have time, although you can grab me later. And I also have to do 2 disclaimers. One is we're discussing unstable features that are not final. So the exact APIs that I show here will change. Don't take them literally, but we've just focus on the ideas because the ideas will stick around, right? And the second thing is this is something I've never done before. I'm doing an in IDE talk. This is VS Code. I don't have slides, and it's live coding too. This is an idea I got from Andre Saltz. Just because people are more engaged, right? This is something you look at every single day, and if I code along, I think people can follow in and understand a lot better. So if anything goes wrong, I've rehearsed this a lot, so it won't. So I'm going to start off the talk by discussing what technology means to me. So this is even more broad than just React, but just I like this quote by Alfred Whitehead. Civilization advances by extending the number of important operations which we can perform without thinking about them. And essentially, that's what technology is, right? They abstract things for you, they automate things for you, so you don't think about them, so you go do something else with your life. And so, and another way to look at it is what is the right abstraction, right? And non-leaky abstraction that you just say, all right, you have a job to be done, you do that job, and then I can go think about something else because I have total trust that you're going to do that. And I think a lot of getting the right abstraction right is about defaults, choosing the right defaults so that you can set and forget. And then only if you need to tweak something for your personal situation do you configure it, right? So opting out of the default is important, but setting the right default is even more important. So what I'm here to assert is that React has 2 new defaults in its feature, and you should be aware of them. And it's not so much about the exact APIs, and we can talk about names, we can talk about should this argument go after the other, but really what are the defaults that are being chosen? And that's going to be more fundamental and more persistent throughout all your future usage of React. The 2 I'm asserting are that React will be concurrent by default, and that it's going to be immediate mode by default. And we're going to explain those just in a second. So let's talk about concurrent. What's the definition of concurrent? I looked it up in Merriam-Webster, and it's very convenient that they broke it out like this: operating or occurring at the same time. And that's very convenient for me because we're going to talk about those separately: operating at the same time, occurring at the same time. Let's talk about occurring. So for this, I have to do a demo. You may have seen a version of this before, but I adapted it to pay tribute to Stan Lee. So here's an app with all 296 characters that he developed over his 95-year life. I don't know, but a lot, right? And I'm just going to walk you through this app, and we're gonna explore the new defaults in React with this app. Okay, so here I have the source code for this app. I've extracted. There's some imports. Don't worry about them. I've extracted this, and basically this is a list and detail view, right? We have a list at the top level, right? It's pulling some number from context, and it's passing that number into the detail, the hero card here, and I have index 0, index +1, index +2, right? Hopefully all of you can see this. And then in the detail view, each detail component is responsible for getting its own data, right? When the component is mounting, and then while it's rendering, it's gonna show a timer, right? And once it's done getting the data, it's gonna set its own state. And once it's set its own state and the state's not null, then it's gonna show its card. So this is a very sort of simplified version of what a lot of apps do, right? Like, and you can see the little timer going on here. The other thing I should explain is that I've set up my backend and my component to accept a delay parameter where I can arbitrarily tweak the amount of time that it takes for my API to respond. So here I have my API responding in 100 milliseconds, and in the middle I have my API responding in 1,000 milliseconds. And you can see a typical sort of unintentional loading state situation here. I'm going to refresh and watch 1, 2, 3, and then the middle one loads and the bottom one jumps around. So like this kind of stuff, like you don't have this exact app, but you've coded this, right? Like everyone in the room, yes, agreed? Yeah? Okay, I see a lot of nods. Right, so this is synchronous React, right? And what we don't like about this, it's gonna show 3 spinners. I don't know if you can see this, right? Yeah, it's good. It's gonna show spinners even if the data loads almost instantly. So let's change this to 100 milliseconds too, right? It's gonna reload, and even though the data loads fairly quickly, it still shows up. And the UI may jump around based on loading, right? Which is what we saw earlier. So that's stuff that we don't want. I'm gonna and we're gonna fix that going forward as well. One more thing that I'm gonna introduce here is the idea of the default state, right? What we've introduced so far, like I pull this number from context. The context is set from this little box that is too small to see here. It's just a number selecting the ID of like what the top card is going to show. So let's bump this to 10, and oh, it doesn't update. Why doesn't it update? Has anyone who's seen what I've been showing figured it out? I bumped it. The context updated. Why is my card not updating? Because I haven't implemented something. Right? So a lot of times when we load stuff in our detail components, right? We put our loading information in loading code in component did mount, and then we forget the component did update stage, right? So here obviously I've already coded it. I didn't forget. And now when I bump stuff up around, we can see Fin Fang Foom as number 101. He's when you have 296 characters, you start scraping the bottom of the barrel. There's more, right? Like there's a third lifecycle that I haven't mentioned. So what if I'm fetching? Let's look at the console and just ignore these warnings. What if I'm fetching, right? Let's say I bumped this, and remember the middle API takes 1,000 milliseconds to respond. So let's say I bump this, and then I switch away, and I unmount. Ah, crap. It's too fast. Okay, so bump this, switch away, unmount. Okay, so here, you see this error? You've seen this before, right? Because I unmounted and my API resolved, and then it tried to set state on a component that wasn't there already, right? And what does every developer do when they see this error? Ignore it. Because what am I supposed to do? Like, do I introduce more state here to say like is mounted? In React we used to have an API called is mounted, and you check that to see whether the component was mounted, and then you set state. But we got rid of that, so it made it harder for you. Do we have a cancelable promise? How do you do that? Do you use ArcsJS? There's all these things you don't bother to implement, right? Because you're like just don't think about it. And this is the default way to do things in React today. Right? So obviously I'm hinting very strongly that we can do better. So the drawbacks that we've discussed of current synchronous React comes out of the choices that we want. The detail view controls its own data loading, right? This is the detail view. Let's zoom out. This is the detail view and this is the list view. Detail view controls its own data loading. The list view has no knowledge of the children's state. So the list parent has no knowledge of whether the children is loading or not. If I wanted to know whether the children is loading, I had to lift the state up, right? And put the state all at the component, all the top component. But that breaks the component clean sort of componentization, which is the benefit of React. Or you have to put in like a Redux controller somewhere. Like it's just like all these infrastructure. And siblings have no knowledge of each other, right? Each of these card components are going to load. When I have my data, I'm going to load no matter what my sibling is doing, right? I don't care about my brother or sister. So these are and those are all like sort of defaults, and maybe that's not something that we want. So we're going to talk about suspense, and with that, I'm actually going to do coding for the first time. and refactor. So the way I have it set up here is I have a synchronous version of my app, and I have the source code for my app as well. This is synchronous, and then this is concurrent. So we're going to move to the concurrent version now. Over in the concurrent side, I have the exact same code, and we're just going to refactor this together. And so here we have a class component, blah blah blah. Don't care. I have a function here called create resource. So I'm going to turn this data loading thing, right? That wasn't working very well, right? Remember we did all this, and I'm going to get rid of all of it and then just redo it from scratch. So this get info function is where I get my promise. It returns a promise, which returns the data that I load. So here I'm just going to get so first thing when converting to React Suspense. Well, okay. So I'm just gonna convert to a function because why not? Because I don't need state anymore. I'm going to get rid of all of this stuff because I don't need that anymore. I'm going to get rid of the render function because why not? I'm just going to return JSX, right? And instead of tracking my loading state and manually set stating and doing all of that, I'm just going to take advantage of the resource that I get. So let's call this an API resource, and let's create a resource out of the get info method that we deleted earlier. And this get info method is a function that returns a promise. So now we can get info. So let's just say API resource.read, and then we pass in the information that we wanted. That we usually pass into our props. And the last thing to do with that info once it's fetched and suspended is to spread it out with the card component. So over here we have, and I can turn on simultaneously. Oops, it looks like I have an error, of course. Oh, this is a planned error. This is going to be a planned error, and I was going to fake forgetting it, but I actually did forget it. And so what we've introduced here is a suspender in our component. So our child component over here is suspending through the top, right? It's going to try to read the resource, and it's going to try and read that cache, and the cache is going to be empty, so it's going to throw a promise up. We need to catch it somewhere, right? So let's just catch it over here. We have a component called Suspense, and we're just going to wrap it among all of my 3 children, right? So if each of them are going to throw up, and we're all just going to catch them in this sort of error boundary, but we call it Suspense. And I need to provide a fallback, right? So I'm going to provide the same fallback, which is the loading component that I have, which is a timer. So that would work. That would do it. So here I can see, if I can get rid of this console, I can see both my synchronous old React and the new React page. So watch out when I refresh. There's only one spinner, and they only appear together when all 3 components are loaded, right? So these are the new defaults. Structurally, these apps look exactly the same, right? The code may be a little bit shorter. It is a lot shorter, but it doesn't matter. And what I want you to see is that the parents don't have to know about their children. Siblings don't have to know about each other, but they all appear together concurrently, right? That is the meaning of concurrent React. So hopefully that makes sense. I should also just play around with this. Like, is this comfortable with everyone? Just kind of doing that, and also just. These inconsistent loading states are also because the API takes a while to load. Whatever. It also is, there's so much, I encourage you to play around with this because, in fact, you can even go to the network console, right, and see when requests are fired out. Here, I'm going backwards over things I've already rendered before. So these are 3 API requests just for these three on the left because there's no concept of a cache. Here, everything is cached, so I don't have to fetch stuff that I've already fetched before. So this is very convenient for apps, like apps that have persistent data. Obviously, you can invalidate the cache if you need to. So, all right, cool. That was a nice digression, which I wasn't planning. So, our app is still this detail view. Detail controls data loading. This is no longer children state. All those things that haven't changed. But what has changed is that siblings appear together, and that's concurrently. The result is that we only have 1 spinner. Unless the data is cached, then we have no spinners. And it only shows when everything is loaded without UI jumping around. That's the new default. I didn't do that much work. Like, I'm not that experienced at this. So that's the first kind of concurrent, that things appear together. The second type of concurrent is that things are being worked on at the same time. Multiple things are being juggled. Unfortunately, that's harder to demo because it's not done yet. So I don't have a thing to show you here today. But I'm going to walk you through the theory of it just because it's so important to how all of this works. Here I have a standard component. It's got a state. It's got a change handler. It's got an input, right, which takes that value and takes the change handler. But in between, it's got this expensive calculation going on, right? It's going to take that number and like run some crazy algorithms and solve for a Bitcoin or something. And then it's going to output the result of that calculation in a sibling component here. Now, what happens when I type into this input? That's going to fire off a set state, and that's going to run straight into this expensive calculation thing. And the update to my input never shows up. Does that make sense? You've probably run into this before. This is a performance issue, right? And in the future, with time slicing, essentially what React has is a sense of priorities of updates. Not all updates are created equal. Some we want to show up faster than the others. And even though chronologically they appeared after one another, you want some high priority updates to just show up first because they're high priority. And what is amazing about React's API design, right, is you can do this. This is literally how you do it. Defer this set state, put it in there. That's it. This is now a low priority update, and everything else that goes on, including the sibling input, which depends on that same set state, works just fine, which is like absurd. And I'm gonna go a little bit. This is like super in the weeds, so feel free to tune out. But if you're interested in how this actually works, like this is understandable by mere mortals like me and the rest of us. Read the source code. Read the comments in the source code for React Update Q. And this gives you an idea of how React does time slicing. It doesn't have two queues. It has one queue, and it works on them multiple times. It's a multi-pass render is what I call it. So let's just say we have four updates that we're scheduling by setting state, A, B, C, and D. But each of them have different priorities. Priority 1 for A, priority 2 for B, 1 for C, 2 for D, right? And one is higher priority. So what we're going to do is, given this set of updates that we have to process and render, right, we're going to go through the queues multiple times. First time, the first pass, I'm going to look for priority 1 updates, right? And only A and C fit that criteria. So I'm going to render quickly because these are high priority updates. I'm going to render quickly and just render the result of A and C happening. Then once I'm done, I'm going to go back again. I'm not going to start from scratch because I've already rendered A, and A is shared between both of them. So I save work there. And I start from A, and I keep going. I'm going to pick up B, C, and D, and then render everything up at once. So that's what the final stage is called flushing or committing to the DOM. And that's kind of how React does its multi-pass update queue. I think it's fascinating. I don't know if I've lost the room here, but this is super cool that it's going on in the background, and you kind of don't know that you're employing React to do this. The way I like how Dan Abramov explained this in his JS Conf Iceland talk, where he talked about how synchronous React just kind of worked on updates in sequence, right? Set state, and if one of them was more expensive than the other, then you're out of luck, right? Like, it's too bad. With time slicing, you're able to fork off into a different sort of, essentially a different branch, have that work, and maybe it doesn't finish, whatever, but you can keep on rendering your high priority updates first. And only when you're done rendering the expensive update, merge everything back and flush it to the DOM. I'm using those specific words because we're going to call back to that later. So just to recap, we've talked about concurrency. Well, not concurrently. I don't know. The word concurrent is overloaded. But basically, concurrent by default to me means for React Suspense that siblings suspend concurrently. And in time slicing, priority queues render concurrently. You're sort of working on both at the same time. So hopefully that is crystal clear. I really want to hammer this to death. So that's the first half of the talk. The second half is more about immediate mode. Whoa, did I? Okay. Oh, wow. All right. The second half is more about immediate mode. But first, in order to do that, I have to talk about hooks. So hooks, whoever was asking the question here, are a new API. You don't have, again, they're backward compatible. You don't have to know them for your job. Don't worry, you're not out of a job if you don't adopt them and rewrite your code base. But they're a new feature proposal that lets you use state and other React features without writing a class. So when I first learned about it, I was like kind of very uncomfortable because like they essentially doubled the API surface area of React, and React is supposed to have a small surface area. But this is just so that we're backward compatible, and eventually, if enough people start moving off of classes into functions, they will know that it's like an experiment, and we're doing an experiment in public. They'll know if it's a success or not, and then they may deprecate classes, but there are no plans to do that at the moment. There are 4 hooks that you should get intimately familiar with. Like these are so useful. I just had so much fun writing apps with them. So use state, use effect, use context, and use ref. We're going to start with use context first instead of use state because we already use context in our app. So let's start this refactor, and then we'll talk about how to use them and what the new defaults are here. So let's switch back to our app. And what is going on? Okay. So let's see Black Panther again because I like him. Did you know that Black Panther was only out this year, the movie? That's a long ass time ago. Yeah? Oh, nice. I'm sure there's a sequel coming on. So the first thing about hooks is that you have to use them in a function component. So let's get rid of classes. This is my favorite. Again, like this, it's not about like that React developers hate classes, but if we don't need them, we don't have to have them. So again, get rid of the render function, and then we don't have static types in functions, right? So we need a new API. So instead of declaring it like with this new context API, let's get rid of that. No more this. Let's get rid of that, and let's just React to use context. And literally, what this is, it's just reading from context. So it's not really like a major refactor. You can see that it still works the same, and I can bump numbers up and down, and the app responds because the context flows down through the app. So that's interesting, and notice that my entire app is function-based now. But we're not done yet, right? Like that's only the first many hooks, and we'll talk about those as we sort of go along. First, I want to set the stage with what immediate mode is. So immediate mode is a term from graphics programming. I've never done graphics. Some of you may have, so this may be a repeat for you, but a lot of us haven't, right? Because we never thought about it that way. Immediate mode is, when you think about graphics programming, when you think about being a user interface engineer, which we all are, you're rendering something out for people to see. And it's a scene, it's an app, it's a site, whatever, right? How do you do it, right? In immediate mode, you're rendering it out the entire screen every single time that the user sees it. So if you render 60 frames per second, you're rendering 60 full frames every second. In retain mode, you actually just keep around whatever has been rendered, and you only bump the pixels of what's changed, right? That's the concept of immediate versus retained. And obviously, immediate seems very wasteful, but it's very easy to be declarative about it because you're just declaring the entire screen at the same time. In retain mode, you're only bumping things, but you have to figure it out. The onus is more on you. So that's hopefully you're seeing the parallels to JSX. And in the DOM APIs, this is how DOM APIs. Do you remember how this looks? I don't know. It's like some people learn web development without learning this anymore. And I mean, maybe they don't have to, I don't know. But you declare things, you have things imperatively, right? You declare stuff and you bump manually each one of them. If you get things out of order, you're screwed. And it's just, it's faster because you're only moving the bits and whatever that need to be moved. But it's more imperative, so it's easier to get wrong. The trade-off for JSX and virtual DOM and all this stuff that's good about React is that all of this becomes this one-liner over here, and isn't that pretty? That's gorgeous. It's less efficient because this converts to a bunch of React.createElement calls. But who cares? Like we have it's very, very minimal load because of what React does for you, and it's more declarative, so you can build, compose, and structure your apps more declaratively. So that's immediate versus retain mode. But this is for the DOM, for things that you see. What else is what else is sort of missing from there? Anyway, I don't want to give you the impression that React is only immediate mode, right? Because there's all these life cycles. Component did mount, component will mount, or I don't know. And what I call React, actually I tweeted this today, is the DX mullet, developer experience mullet. It's immediate mode in the front, but party in the back. And you see this a lot with like, it's so good to have things that are immutable because you can trust that they have never changed, right? I love immutable URLs. I love Git where like that hash is like the thing, like you know that like everything in that file is correct. Immutable JS, static site generators, Netlify, which you should definitely try out. And then we get to effects, right? So this is retain mode inside of like our class-based React, right? This is like we're declaring this, and then we like move this there, and then oh yeah, don't forget did update. We do stuff here, and then will unmount. I would just leave that as a / to do. So what is the immediate mode equivalent for all this? This is retain mode, right? Like we're bumping things manually. So let's try this out on our app. And the way I've chosen to do this is let's talk about the timer component. So the timer component is this little swirly thing, and the numbers are running up as they sort of load. So let's show you the source code over here, and this is coded in classes, and the class basically starts like this, right? You run when you initialize. You set the start time, it's performance.now. You can use date.now, but it's less precise. Then you set the starting time as well inside the state. Inside component did mount, you set a set timeout that schedules the set state for the current time. So basically, you're just setting the current time, and then every time it updates, you set another set timeout for the current time as well. And when you're unmounting, you clear that timeout. And for the render, you're just calculating the difference between current time and the start time, and that's how you get the time that's elapsed. Is everyone clear about how the timer component works? Right? So that's how you get this nice sort of running number to show you how long things take to render. So let's refactor this whole thing because we're using hooks now. First thing to do is to use functions. And no render. And then that's our initial sort of refactor. And now we have all this stuff left, right? So I'm not about to just delete that and say that the code would work. That would be awesome. But I'm just going to show you like the one-for-one parallel that you can do everything that you can do in classes in functions, and talk about why the new defaults are starting to appear. Okay, so here we have an instance variable, right? This is attached onto the class component, this.startTime. So now we're just going to, instead of an instance variable, we're going to use a ref. So it's literally called useRef. You're probably familiar with refs as attaching to DOM nodes, but in hooks, you're encouraged to use it for anything that you would normally use for an instance variable. So here we're using it for a number, and that's totally fine. For state, we have a different hook. We call it state, useState. I'm going to call it time as well. I'm going to destructure it from here. And blah, blah, blah. I'm getting pretty warm, but it's good. I'm on fire. So that's the useState hook, right? Again, not so alien, but this time you're not forced to use objects in your state. You can sort of break them down into the primitives of JavaScript. useState also gives you a setter because you still need this.setState, right? You still need the equivalent of that. So every piece of state now comes with its own setter. So let's call it setTime. And that's about it. We should refactor this stuff at the bottom as well. So instead of this.startTime, because it's a ref, I have to use this current thing, which I don't really like, but whatever, that's how it works. And then we can use time over here. So hopefully this is a four-line function component. Hopefully you're following along. And now we come to the side effects, right? The things that are not declarative, the things that are not visual. How do we take care of this? React has a lifecycle called useEffect that is a generic asynchronous thing that you sort of schedule and let it run. So let's do that. We do React.useEffect. It takes a callback, and inside the callback you can do whatever that you would normally do asynchronously, but it combines the concepts of component did mount and component did update because you do so much of those together to keep things in sync, right? To keep things up to date. So we're going to call the setTimeout, for example. And we're going to pass it a callback because that's how setTimeout works. And then we're going to set time. And we'll call performance.now. And at this point, the app actually works. Well, if I can spell performance.now. At this point, the app actually works. So we've just done the refactor, but it's not quite good yet. But I mean, just hopefully you see that how much more concise and how much more declarative this code is already. But I'm still not super happy with it. What's wrong with this app? So first of all, if I navigate away, it still doesn't do the unmount, right? I still need to do the unmount, and then the API for useEffect tells me that to specify the unmount action, I return a callback, and I put in whatever I want in there. So what I want is to give an ID to this set timeout, and I'm going to call clear timeout over here, and that's the component will unmount equivalent of set time inside of hooks. Something I'm still not very. So that's it, right? So we've just gone through use context, use ref, use state, and use effect. And something I'm still not super happy, and this is like a bonus, all right? This is like not final yet, but this is so cool. Look at this. Look at these numbers. It freezes there. Do you see that? You see it freezes there? Because I've hard-coded this to show up at 1,000 milliseconds. It only gets up to 300 and then it stops because it's doing all the work of the render. So we haven't opted out of the render yet. In fact, what we actually want is for the timer to when it's rendering its numbers to be high priority because it's got to show up. So I showed you defer earlier, which is to set things low priority. How about let's set things higher priority and move the priority up? So let's wrap this set time in this undocumented, totally cool API called FlushSync, and I'm going to put it in there. Watch the numbers. So it's updating. You're declaring, right, the priority of your updates as just wrappers around your set states. Right? Lower priority, high priority, I don't care. Like, there's no big refactor. You don't have to move things to like an asynchronous promise or whatever. That's our refactor. That's what I'm asserting, that the equivalent of this, right? I'm going to put these side by side just to really drive home the point. One is retain mode and one is immediate mode. UseEffect runs every single render, and it runs on component did mount and update, and it's got an equivalent for unmount as well. And I don't have time to talk about it, but it's the same feature. So UseEffect is a side effect, but setting state is also a side effect, and it runs the same way in immediate mode as well. So I think I've covered like a lot of the stuff that I wanted to cover. So just to recap, yeah, have I missed anything else? No, I don't think so. Okay, so just to recap, React's new defaults. What are they? Concurrent by default, immediate mode by default. What does concurrent mean? React Suspense, siblings suspend concurrently. Time sensing, priority queues render concurrently at the same time. Immediate mode by default, just like render, the render function, let's just like put this, just like render runs every render, effects now also run every render. So you're less likely to forget component did mount. You're less likely to forget component will unmount. You're better able to group these things together. Oh, this is fun. So let's pull up the apps side by side. This is so on the right is classes, and on the left is hooks. Imagine this is one functionality of timer, right? What if you added a second piece of functionality? Where would you put it, right? So you're interspersing on the right. If you're adding analytics, you're interspersing on the right inside component did update, and you need to make sure that these things don't screw up, right? Whereas over here, this one use effect is responsible for time, and you write another one for analytics. You write another one. And they're grouped by functionality rather than the weird lifecycle you don't care about, right? Like that is fundamentally better. So that's what I really want to drive home. I have two parting things, and then we're done. So in general, when you encounter new APIs, there's a hierarchy of new API designs, and this is how I think about it. You know what bike shading is, where people talk about the color of the bike shade instead of like discussing the design of the building. That's what a lot of response of hooks and suspense has been, like naming things, the syntax of things. Who cares? You can rename things, right? You're developers. Like there are a lot of very valid alternatives to what they pick, doesn't matter. You can write wrapper libraries. It takes you like a second. It doesn't matter. But what I think is long-term important and people don't talk about enough is the opinions that are enveloped within these new sort of frameworks and initiatives, right? And my assertion is that the opinions of React are that your apps should be concurrent by default, and your app should be written as though they're immediate mode by default. In other words, they should have you deserve a better abstraction from your front-end framework. And again, that quote again. So that's it for me. Hopefully that talk was sort of compelling and interesting on its own. You can find this on GitHub, or you can find me on Twitter at Swix, or you can email me if you are not comfortable with Twitter. Thank you very much. Any questions?